All right. Can you hear me? Yes? Okay, great. Thanks for that really nice introduction. A bit awkward, but thanks. Happy to be here. We're going to be talking about cutting edge continuous delivery um, and specifically about automated Canary Analysis. We're going to be using a tool for that called Spinnaker. But in general, the idea of automated Canary Analysis is the most important part of this presentation. Let me first introduce myself for people who don't know me. I'm a solution architect at Pivotal. I work in the application transformation practice for EMEA, but I'm also active in the Spinnaker team at Pivotal, which is a collaboration between the Spring team and Cloud Foundry or Pivotal R&D in general. And I used to work at JWorks, so I know a lot of people here. Yay! Awesome. And you can reach me on Twitter, of course, as well. Also, after this talk, if you have any questions and you can't find me, just let me know on Twitter. Cool. Yeah, this is a bit what I do aside from Spinnaker, AppTX, transforming companies towards the cloud and cloud native practices and stuff like that. But that's not what we are here to talk about. We're here to talk about continuous delivery. And when we talk about that, the ultimate goal that we try to achieve is to deploy software quickly and automatically. Right? That's what we want to achieve. But that can only be achieved if we're able to push new code without fear. And that's, I think, a very important notion here, because throughout history of software development, we've always been fighting in this battle between two opposing forces. On the one hand, we've got speed. We want to go fast to production. We want to create business value as quickly as possible. On the other hand, we want confidence that whatever we deploy is actually going to work. Right? That's pretty straightforward. When I started development, I think I don't know how many years ago now, but I kind of had projects where people were deploying software by hot swapping code in production, and that's a lot of speed, right? It's really fast. It's instant, but that doesn't give you a lot of confidence. So to avoid that, we started to test our code, right? First manual tests, but that got expensive, especially if you have a big application. Regression tests do cost a lot. We started to get these huge number of testers, kind of an army of testers to help you out to make sure that you can go to production with some kind of confidence. And that kind of led towards these release cycles, because it's so expensive, so you want to group these efforts and test everything at once for all your features and not just one feature at a time. Now, of course, that's not really fast, right? So what we started to do was create automated tests so we can run this automatically. And that kind of gave us speed, but now that we move to more modular architectures like microservices, and who's doing microservices here? So almost everyone, right? Or just modular architecture in general. It's really hard to have full confidence when you go to production, because you're actually testing against a moving target. Whenever something's in acceptance environment and you start testing it, the moment when you want to go to production, probably things have already changed, because that's the nature of microservices. These independently deployable applications just go to production whenever they can, whenever they want to, right? So there's no idea of no concept of release cycles anymore. So it doesn't really give us a lot of confidence anymore. So what we could do is we could again dial back speed a bit, have these release cycles again. That's not what we want, right? Because that's against the very idea of microservices. So what do we want? What do we need to do is think about other ways of testing. And one of these ways is, for instance, consumer-driven contract tests. Who's heard about that? Consumer-driven contract tests, right? Pact or Spring Cloud Contract, for instance. These things are really great, but they only test your syntactual contract. They won't test your behavior of your application. Right? If you're returning a similar value as before, it's not going to fail the test, right? Because it fits into the contract. But what if that value is actually completely different in terms of meaning, in terms of behavior? Then we actually have a problem. So what can we do to still have speed and make sure we also have more confidence when we go to production? Is to start actually testing on production, right? So that sounds a bit weird, sounds a bit crazy, we're gonna see some tools like Spinnaker who will help you with doing this testing on production in a safe way. So that tool is called Spinnaker. So Spinnaker itself, let me just introduce it for a second. Spinnaker is a continuous deployment tool for multiple regions, multiple clouds. Right? So it can actually handle multiple abstractions like Kubernetes and Cloud Foundry. Also App Engine, also different container orchestration frameworks like, of course, Kubernetes itself, but also DCOS. You can even deploy this, you can even use it to deploy on OpenStack or just on bare metal or on any of the major infrastructure as services. So this tool here is built by Netflix originally. They had a tool in-house called Asgard, but they kind of saw some really strong limitations in that tool, so they rebuilt it from scratch, and they've open sourced it. And at that point, Google has invested a lot of energy and time and money into this tool. Microsoft has committed the integration with their Azure cloud, of course. Pivotal has integrated Cloud Foundry. Oracle, the Oracle cloud, of course, and a number of other companies are also actively developing features for Spinnaker. So it is really a really big community behind this. Now, when I talked about Netflix rebuilding it, they've rebuilt it in a way that we can all enjoy if you're at least using Java. Using Spring Boot, it's very, very familiar if you look under the hood. It's just a number of microservices, if you can call them microservices at least, of Spring Boot applications with an Angular front end, which they're rebuilding to Reactor at this time, actually. So pretty straightforward. The whole community who's using this is quite vast. You can see maybe a couple of them, like Under Armour Waze. Waze is heavily using this for their immense traffic to route it when they go to production. Also, JP Morgan Chase is using this. There's going to be a presentation about how they use this at Spring One next week. I think it's the biggest bank in the world, if you look at market capitalization at least. So even for these huge banks, where you think, well, they can never test in production, right? That'd be crazy, because they're a bank. Well, they actually start using this Canary Analysis. So also Ordina, by the way, have used it at clients, so that's pretty cool. It's joined the Linux Foundation. So it's now contributed by Google and Netflix to its separate foundation. Actually, it's a continuous delivery foundation itself, and its ecosystem consists out of many different options. So we talked about cloud providers already. So you can see we have a whole bunch of different abstractions there. For our demo that we'll be giving, I'll be using Cloud Foundry and Kubernetes. Which one are we using the most? Kubernetes. Right, and Cloud Foundry, only a couple, right? So let's use Kubernetes, right, to keep it more familiar for you. CI systems, so you can integrate this with CI systems like Jenkins, Concourse, Travis, Worker, and so forth. We'll be using actually Google built as a CI service. So the Google Cloud Platform actually also has a build service. So that's perfectly fine. Also, I'd like to point out that CI system is here separately because Spinnaker is not a CI/CD tool, it's just a CD tool. It just supports continuous delivery, right? So it's really focusing on deploying applications to the cloud. Right? So that's kind of the distinction here. CI system will build your artifact, and Spinnaker will then pick up that artifact and deploy it in a specific strategy. Now, you can probably think like, or wonder like, okay, why do we need a separate tool? Jenkins can do this for me as well. We are deploying currently to Kubernetes with Jenkins, so why do I need a separate tool? Right. It's true, but there's a bunch of scripting that you have to do, and all that stuff is repeated for every team, and all these things should actually be contributed by the cloud provider themselves, well tested, well supported by the community. Now, in terms of monitoring, because if we're going to be doing automated Canary analysis, we'll be needing metrics to measure how well our Canary is doing. Monitoring is supported for Datadog, Prometheus, Stackdriver, Atlas, SignalFX, and a lot more. And the only important thing here is that you have a monitoring solution that supports multidimensional data series. So that's important, not just one-dimensional. For notifications, of course, you can use email, HipChat, Slack, whatever. And artifact support. So artifact support is kind of your deliverable, your binary that you're going to deploy. That can be in Docker, that can be on GitHub, HTTP, S3, and so forth. And we will be using S3 as a bucket. Or, hold on, no. We'll be using, I think, the Docker registry of Google. Right? I just changed this overnight. So we can be using that for our Docker containers that we will be pulling from there, or images at least. Now, Pivotal has already something for continuous delivery. It's called Spring Cloud Pipelines, right? Where we kind of have this cookie cutter approach to making sure that you can have a pipeline in Jenkins out of the box, right? Now, that actually got rebranded to Cloud Pipelines because it has nothing to do with Spring. That's one thing. But also, the Spring team has completely shifted gear here because the idea of having a Jenkins pipeline for deployment is limited in many ways. And the biggest bottleneck there, the biggest limitation is that how are you going to keep track of what's actually in the cloud when you're using Jenkins? One solution would be that you would tag in Git your current deployed containers, right? You could say, well, this piece of code is this commit right here is now deployed to production, right? You could definitely tag that. But the problem is, if you want to have more sophisticated strategies to go to production, and we'll be talking about that in a minute, how are we going to tag that? What if you have multiple versions in production at the same time? Right? Sure, you could still tag that, but if you then want to roll back to specific versions, it gets really tricky. And the problem is, if you have any manual deployments outside of Jenkins, then you can screw this whole thing up, right? Also, just next to production as an environment, what if you want to keep track of regions, of accounts, of different cloud providers that you're using? And that gets really, really hard. So the Spring team also shifted gears towards Spinnaker, because Spinnaker has one big distinction here, one big differentiator, and that's called the inventory. So Spinnaker keeps track in real time of all your resources deployed to all your different clouds on all your different regions across all your different availability zones. And it's super powerful. And you can use that information of what your current landscape looks like to drive your pipelines. Now that's a key difference with Jenkins. So we're going to see how that works in a minute. So now, when we actually go to the cloud, what are some things that we have to watch out for? I assume many of us here are familiar with the cloud. Who has done cloud deployments? And who is currently, for instance, on Kubernetes? So that was like 1/3, right? So when you're actually on Kubernetes, things get a little bit more complex than if you have a separate ops team, for instance. So you have here different teams, different people in different teams pushing multiple different changes across different services to different availability zones, perhaps even different providers, cloud providers, right? So this entire the sum of this complexity makes it really hard for us to have a view of what's currently going on. So having multiple different foundations or clouds or different accounts or different regions in one dashboard is really interesting for us to understand what our application is currently doing in production. It can even have development and production in the same dashboard, as you can see here. It's also important, if you go to the cloud, that teams don't really feel lost, because this complexity can be really overwhelming. So having this paved road where our teams are getting this easy onboarding, that's really important as well. Next to that, rollbacks, always a difficult subject here. Rollbacks, because when you're doing a rollback, you're often under duress and you don't really know what's going on. You kind of try to fix it as soon as possible. So that's when you make mistakes, right? So having some guidance as to what the tool will automatically do for you, which steps will be undertaken, can really be beneficial here as well. Also, when things go wrong, because things do go wrong, right? Then we want to make sure that we that we don't have that we don't have a big impact, right? So, does anyone know this picture here? Anyone has seen this before? Yeah. From where? Where did you see it before? Exactly. Well, you okay. You've worked on GitHub before, and you've seen it go down. It's kind of not so common, right? They kind of have this logo or this image here to say, well, this doesn't actually happen because unicorns don't exist, right? So they try to make sure that the blast radius of downtime is as small as possible. So it's important to have in your pipelines some kind of configuration where you can say, I want to have my my deployments completely prepared up to the point where I actually switch over the traffic. And at that point, I wait. I wait until there's less traffic, for instance, if I can couple that back to my my live traffic view. But also if there's actually people in the office, because if I look at normal traffic at night, it's often lower, but then there's also no support. So when do we want to deploy? Now, Spinnaker kind of has support for that. So let me just skip that. So this is, for instance, the deployment window analysis that I can do. And you can just say, okay, I want to deploy within this time frame specifically. Right? But when you actually deploy, you want to do that in the most strategic way possible. And there's a couple of strategies, of course, that we already use for a long time, like blue-green deployments. Blue-green deployments, it's pretty straightforward, right? You just bring up a cluster of the new version next to the existing one, and you switch over the traffic through switching the load balancer. And that's just instantaneous, right? Also, the big benefit here is when there's something wrong with your new version, you can just switch back right away. It's a really easy way of making sure that you can have quick rollbacks. The downside here is that one, you're using a lot of resources because you spin up an entire cluster next to it. But also, when there is something wrong with your Canary or with your new version, then you have your entire user base impacted. Right? Everybody who's actually accessing your application at that point in time will be impacted. How to solve that? You can do rolling blue-green. And with rolling blue-green, you bring up one instance at a time, or you have sophisticated load balancing strategies where you increase the load to the new versions, let's say 1% at a time, right? Now that's a powerful way of making sure you have used less resources, that's one, but also that you have a smaller blast radius. Now the Canary approach is an extension of that. Canary analysis, Canary deployments is actually just the same as rolling blue-green, but whenever you go from one step to the next, from 1% to 2%, for instance, then you'll actually check if whatever is running on production, the new version, is actually doing well compared to the old version. In that way, you're certain that actually whatever you deploy further in that pipeline will actually be working. Okay, and it's doing that based on metrics. So it's going to be comparing the baseline with the Canary version, and it's going to compare those metrics and seeing if it's healthy, then it's going to roll forward. If it's not healthy, it's going to roll back. We're going to be seeing this in action today. There's actually Canary deployments happen a lot, but automated Canary analysis, we're going to check whether this is actually working by an automated process, an automated judge that can see whether these are actually better or worse metrics. That's the differentiator factor here. So when you want to do any of these strategies, you need to make sure everything's automated. I already mentioned you could be writing your own Jenkins scripts, right? That's possible, and we did this a lot, I think, at least I did. Now, if you look at a normal production deployment here, for instance, where you do a Canary deployment, you just wait 30 minutes, you have a manual cutover, you deploy in blue-green fashion to production, and then you tear everything down and you destroy the old versions, for instance. Then you could do this in Jenkins. It's perfectly possible. You could script all this yourself. But if you look at what Spinnaker's doing, for instance, for just the blue-green, It's going to have for each stage a number of steps that it's going to go through, and these steps result in a number of tasks, who all result in a number of operations. Now these operations are low level, and you normally have to script that yourself, or you would just not do that and have a less robust solution, or you'd make some mistakes here and there. The only way to test this, if you do it manually, if you do it yourself, is by running the pipeline over and over again. And why not just have this as some kind of a framework that has been contributed by the clouds themselves, right, and has been tested and guarantee that it works. And that's the approach to automation from Spinnaker. You can just create your own pipeline combined of a number of stages that are predefined. Right? You can just configure it the way you like, and you can just use that instead of your own scripts. Now, of course, you need to have operational integration, and that's an important thing when you go to the cloud. It's when you deploy, you want to look at how your application is doing, how it's doing on production. So having this, for instance, the automated Canary Analysis will help you to validate whatever you put in production is actually working, and then it will tie it back into the pipeline for the next step. But also in the other way around, of course, you need to be able to look at your entire deployment pipeline when you're in production and something goes wrong. Right? You need to be able to trace back, for instance, when you do the Canary Analysis, what went wrong in that Canary Analysis so that we can tweak those results. Sorry. So let's talk a bit about Canary, right? That's why we are all here, right? So Canary Birds. We're going to be killing a lot of birds here, right? So I just want to make sure, is there any bird lover in the audience here right now? Anyone? I count 4 people. Okay. Well, for all of you, right, to make sure that your feelings not hurt, I've got this special slide for you. A special canary, but I mean these are super cute, right? Are you more confident now? It's fine, right? Because we're gonna be killing them. Is that's cool? All right, awesome. Let's move on. So when we kill these canary birds, in this case, the canary was successful. It's all good. But you're gonna see a score in our demo, and that score is going to say how healthy the canary is, or rather, down in the mines, it already died from gases, right? It's possible. We'll see what happens. Hopefully, it's gonna work. So we're gonna be seeing something like that, but we're gonna see that more in detail when we do the demo. Also, chaos monkeys are available. So you probably know about chaos monkeys, right? The simian army of Netflix. Netflix built this tool, so there's great integration, right? So if you don't know, a chaos monkey is just some monkey that goes into production and pulls some plugs, right? And then we need to test whether our system is resilient to those monkeys. So you can set that up as part of your pipeline. Now, what we've seen are actually a couple of examples of how you go fast with safety. How you can make sure you have confidence when you go to production while still making sure you can go fast. So we've seen automated rollbacks, deployment windows, chaos monkeys, deployment strategies, and automated Canary Analysis. And these techniques help you to go fast with safety, but there's other stuff as well. Cluster locking, for instance, traffic guards, manual judgments, conditional pipeline and stage executions, and notifications. Now these first 2, cluster locking and traffic guards, so cluster locking itself is when you have multiple pipelines acting on the same cluster, you might want to make sure they are not doing that at the same time, that you want to isolate those changes, because otherwise you're going to have some results that might not be very deterministic, right? So that's something that you can set up as well. And traffic guards, if by some strange combination of pipelines or strategies, you would that would result in deleting the last server group, then you would have downtime, right? You would have user impact. You could set up a traffic guard that prevents the deletion of the last server group, whatever it is, whichever it is. Right, so those are really useful features. So let's take a look at a demo, right? So for the demo, I've got a little scenario here, and I hope you're familiar with it. Otherwise, good luck. It's about Rick and Morty. Anyone who knows Rick and Morty? It's great. So I love JWorks. So Rick and Morty, for the people who don't know Rick and Morty, because I think there was just a couple there, it's kind of a cartoon show. It's for grown-up people, and there's this crazy scientist and this little kid. So he takes this kid along on his multi-dimensional, universe strips or something through time. I don't know. You have to look. You have to watch it because otherwise it's never going to be clear. But there's going to be two different personas that we're going to be using here. On the one hand, we'll have the green protagonist, which is Pickle Rick, and it's kind of the idea of Rick turning himself into a pickle because he doesn't want to go to family therapy. He hates it. But then, he rolls off the table. He rolls into the sewer, and there he's getting eaten by rats. So he has to fight. He has to fight against these rats and cockroaches. And guess what? He's victorious. So he's a really good version here. Very stable, very predictable. He's going to fight for us. So we want to keep this version in production, right? That's green. Now our next persona is the blue antagonist. See, green, blue, green, right? And this is Mr. Meeseeks. And Mr. Meeseeks in the series is just a genie in a box that you can summon. And the only reason he is alive is to solve a task at hand. Now, if he can't solve that task, however, it's kind of bad because he gets really aggressive. Right? After he solves the tasks, he disappears. Great. But if he can't finish it, it's really terrible. And we don't want to keep that in production because it sounds good at first, but after a while it gets super dangerous. And just to illustrate that, the whole episode goes like he's summoned to make this guy play golf, but this guy just can't play golf. But so the Meeseeks summons another Meeseeks, and they summon another Meeseeks, but they just can't make him play golf. So they start to threaten people, and it gets really bad. So we want to roll that back, right? So that's the idea. So let's go to the demo. And you can already take a look at what's currently on production by going to this link here, or by taking a picture of this QR code. Join spin. Right, bit.do join spin, and you can see what's currently deployed on production. We're going to be changing that, right? Or we'll see. Which version? Green? Great, that's the idea. It's the stable version currently in production. So, let's take a look at our application here. Okay. So I've got an application here. It's a Spring Boot application, which is currently green, right? If you go to the link that I posted, so it's super sophisticated application. It has a controller, it has a Spring Boot application, and well, that's about it. It does some metric stuff, but not super crazy stuff. So actually not that sophisticated, right? And our controller looks like this. So if you're a bit familiar with Spring Boot, the idea is that you could go to the endpoint, the / endpoints to the root, and that would give you a view back, which is currently Pickle Rick, right? Pretty straightforward. And if you can see here what this is doing, it's sleeping randomly between 0 and 100 milliseconds. So if you refresh your page, you're going to be waiting a little bit. You're not going to notice that much because it's so small, but still, it's going to make it a bit random, right? So you have metrics that go up and down, right? It's a bit like production, like in a normal application. So we're going to be changing this application, right? So I'm going to be returning Meeseeks this time. And what the Meeseeks are doing is they kind of add some chaos to the mix, right? It's an application, it's kind of a persona that doesn't really behave well. So we're going to be adding some chaos, which means let's make people wait consistently 50 milliseconds extra, right? 50 milliseconds of chaos. So the idea here is that your random is still active, so it's still between 0 and 100. It's now just always 50 extra, right? So just to be aware of what's going on here when we go to production and we compare metrics between these two versions, it could be that if you look at a single point in time, a single data point, that your original version, the Pickle Rick, actually has worse metrics than Meeseeks. If the random at that moment in time is 0 for Meeseeks, it's going to end up in 50, right? 0 plus 50. However, if at that moment in time, our data point for our Pickle Rick, the green version, is 100, it's going to show much worse for Pickle Rick. So the idea here is that our whatever we're using to validate these metrics, to do this Canary analysis, has to take into account trending, right? That's key here. And that's something that you need to compare this. You need some kind of algorithm for that, we're going to be seeing how that works. So I'm going to add some chaos. It's only 50 milliseconds, right? It's not much. Let's see, I have everything. Yes, great. I'm going to commit this through GitHub because that's what all great developers do, right? They work inside of GitHub instead of an IDE. So I'm going to check out how my cloud build is doing here. Since I committed some code, now my cloud builds should automatically start building, and it's doing that. Gotta love it when everything comes together, right? Well, if only everything else works. So let's take a look here. What it's going to do is just going to build this as a Spring Boot application with Maven, and then it's going to build a Docker image. It's going to put that in a registry. So while that's going on, let's take a look at what's currently deployed, right? So here, is it visible in the back? I think now it is, right? Yes, good, great. So you can see we have a dev cluster here and we have a prod cluster. And on dev, we have 2 instances currently running. And on prod, we got 4 instances. It's not that strange, right? It's pretty straightforward. We've got some versions here which are scaled to 0 so that we can easily roll back if something were to happen with our version 5. Right, so normally we should be seeing version 3 coming up here in the future. Now, I've also got some other stuff here, which is Cloud Foundry. I've got 4 instances on Cloud Foundry deployed. Now, so you can see this is completely across all different clouds, all different providers that you would like to use. Oh yes, maybe you're thinking, well, we only have one cloud, right? We choose for Google or for Amazon or for Azure. I don't know that many companies that use Azure and Amazon, for instance. Sure, but you probably also have on-premise, right? So if your application wants to migrate, it would be great if we can see the joint view of on-premise and in the cloud. And that's actually completely possible here. So that's pretty cool. If you look at our load balancers, in the case of Kubernetes, these are just services. And the services here show that we have 2 instances on dev and 4 on prod. So here it shows the delivery pipelines, and one has actually triggered now. So we can see deployed to GKE dev. I'm actually having a cluster deployed on Google, which is pretty easy. What we are doing here in this pipeline is we're going to deploy a namespace. Now, of course, if the namespace is already there, it's great. So what we can do is you can specify the artifact here as a manifest. You don't have to do it like this, but it's possible, right? So I put it here as some text. You can also link, of course, to your repository, and that's what the next step is doing. So I also want to deploy the application into the namespace, and here it's linking to a manifest that is currently in my GitHub repository, right? And that manifest is just going to say, I want to deploy this as a deployment, as a Kubernetes deployment, and it's just going to do that out of the box. So that's pretty straightforward. So if we look at how that's going currently, it's deploying it. So the namespace here, it's available and it's stable. It doesn't have to do anything with it. Great. Then if I look at the application, it's creating a new deployment for me, and it's actually creating 2 instances, I think. Let's see. Okay, 1 instance is already coming up. If I refresh, second one is coming up. As you can see, the deployment itself is also rolling it. And the second one will be scaled down, right? It's pretty straightforward. That's just for dev. So let me check what's currently going on in development by going to the service. So development here, I can go to the service here. So I can copy, go here, and that's the blue version, right? So on development, everything seems good. And as I said, this ME6 initially looks like a good idea because they can help us out, right? So on dev, we are happy with this change, right? So let's roll this out to production. Right, so, okay, let's see what's going on in our pipelines. So my pipeline now has finished to deploy to development, and now it's starting deployment to production. And if you take a look here what's going on, it's actually finding the baseline from prod and finding the canary. Why do we have a baseline and not just the production cluster? It's because if you're comparing metrics of instances that are currently starting with instances that have been running for a long time, it's going to be different, just like that, right? Even if you're deploying the same version. You might have startup spikes, caches that need to be warmed up. There might be memory leaks on something that's running for a long time. So you can't really compare this. So let's just spin up a canary and the baseline, right? The baseline being the same version as production, and the canary being the new version, right? So then we can do canary analysis. So these baselines here are being deployed, and these canaries as well, as you can see here. So if I zoom out a bit, as you can see, there's two new deployments that came up. One which is for the baseline, and one which is for the canary, right? So if I have a look here, currently the deployment is ongoing, right? And let's take a look at the canary analysis itself. So canary analysis, as you can see, we are going to have a score here, and it's starting right now. If you now refresh your page, you might see that sometimes you've got a blue one, right? And that's the canary that's popping up. If I look here at the load balancer for production, then I see that there's now 8 instances currently deployed, 4 of which are just the normal production version, 2 of which are the canary version, and 2 of which are the baseline, which is the same as production. So actually, 2 out of 8 are currently serving the canary, right? So to help you guys to generate some traffic, because we need traffic for metrics, right? I'm going to be generating some random load for you. You can do the same. You can just keep refreshing. And as you can see, some of them are pickle rock and some of them are meeseeks. Now, if I look at the current stage here, is the canary analysis is now ongoing. So what the canary analysis is doing, it's looking at metrics from both the canary and the production version, and it's comparing it. So if I look at the tasks, we are currently, so we've done a warm-up wait of 1 minute. We're past that, right? We just don't want to have these initial startup spikes of CPU memory. And now we're having an interval wait of 1 minute. So we are waiting 1 minute for each interval, and after 1 minute, we're going to do an evaluation. We're going to check if the canary is actually healthy. If so, we're going to roll out. If not, we're going to roll back automatically, right? So let's take a look here. What's going on? So talk status. 20 seconds left to refresh. So let's take a look at the canary config that we're using. What are we actually measuring here? We are measuring rendering time average, rendering time maximum, CPU usage of the system and the process, JVM memory used, and logback events. And as you can see here, the weighting of Rick and Morty here is higher than the metrics, because we care more about business metrics than about the system metrics themselves, which are also still important and are going to fail the entire deployment if they are actually not working. But the business metrics are most important. So here we can see now that the canary analysis actually failed. So let me zoom out a bit, sorry. So it's 30. So we see that things have failed. So let's click here. So the canary report here, it shows that the metrics that came through are way different from one another, right? You can see, you can take a look at the box plot if you're familiar with statistics. The standard deviation between the two data sets are way off, and they're not even overlapping. If you look at a canary report from a successful deployment, like this one here, for instance, hold on, this one here, you can see that actually the data points that are gathered are in the same range. Sure, you might still have outliers, as you can see here, that are completely out of the normal spectrum. It's not going to matter unless if you do this manually. If you manually look at these metrics and compare them at instances or at points in time, then you're going to have a wrong idea of what's going on. That's why we have this random in there as well, because that's just what real life is, right? So this is an important result that we have here. It's now going to roll back. Although I have a manual judgment, I'm going to say continue, but it's not going to matter. So I probably should stop. Well, I can stop, doesn't matter. So even if the canary is successful, we can still have a manual judgment stage in there where we can say, well, okay, we feel confident now, we want to go ahead. This is the difference between continuous delivery and continuous deployment, right? But why is it still important to have this manual judgment in there? It's because it's the gut feeling of a human being. A computer doesn't have that, right? And it's still important to have, because it might be, for instance, that you just heard a colleague say that they're going to change some firewall stuff, right? That could impact your new version. right, then you might not want to roll that out, right? And the computer might not know that. They might know other things, but it might very well be that they don't have the full context. That's why a human intervention is still interesting to have. So what is going on now? The rollout to production, which is a blue-green deployment, is not going to happen because we're not confident. And the canary is deleted and the baseline is deleted. Now if you refresh, it should be the original version again. Is that correct? Right? Yes. Okay. So if you look at the infrastructure here, you can see that everything's rolled back. We have just develop and production and none of the other stuff anymore. Right? It's working? All right, cool, awesome. So let's go back to the presentation. I think we have to wrap up. So some best practices for Canary analysis here. So if you're going to do this, also make sure you have some fine-grained traffic splits on your load balancer. And so right now, what I did was just round robin across the number of instances that I had. So you had 2 out of 8 that were Canary. Now what you should be including in your strategy is that you have some more sophisticated load balancing strategy, where you might even use Istio. Is anyone familiar with Istio here? You might have had a talk about that today, I don't know. Where Istio can then indicate how much traffic is actually allocated to the Canary. Could be completely different than the ratio of instances you have. You also have to fine-tune the metrics that you use. So we use some Rick and Morty metrics and some system metrics. You need to reflect on that and make sure that you're using metrics that are similar to your key service health indicators. But also business metrics should be included. And I don't know if anyone's aware about the pirate metrics. It's called pirate metrics because the things you're measuring start with A and R, so R, right? So awareness, acquisition, activation, revenue, retention, and referral. So these things you probably want to measure as well because they are business scores, business metrics. Well, there's the same slide with extra stuff on it. So you should also align the data points from both the Canary and the baseline deployments using time series aggregators and reducers, right? So you have to really be careful about what you're comparing with one another, right? You should also be using spell expressions. So you probably know spell expressions from Spring. It's because they're the same in Spinnaker. You can also use that to make sure that you don't have to have like a ton of manifests for every deployment that you do, right? So yeah, that's basically the gist of it. So what's coming up? There's a CLI coming up to have pipelines as code. You can already do that right now, but that's JSON. There's declarative CD also in the pipeline, no pun intended. More cloud platforms like Alibaba Cloud is being supported in the future. It's being worked on. Comprehensive provisioning support for Canary stages, so you don't have to create your Canary and deploy and destroy it afterwards. And actually, just continuing to grow and mature the whole community. So the whole story started with speed and confidence, right? So on the one hand, we want speed, but we also want confidence, and using techniques like continuous delivery with automated Canary analysis can help you to go fast while still being confident that whatever you're doing in production has a small blast radius and will actually not impact a lot of people if it goes wrong, right? So that's the idea here. If you want to know more about this, about automated Canary analysis or anything that I talked about today, you should probably check out this book, which is only 75 pages or something. It's for free on the Spinnaker website. So I definitely would suggest that you do that if you have the time, because it really explains the ideas behind Spinnaker in much more detail. And if you have any questions, let me know. You can also check the slides on Speaker Deck, reach me on Twitter as well. You can go to the Slack channel as well, which is for the entire Spinnaker community, which contains also the Google people and the Netflix folks. On Stack Overflow, you can use the tag Spinnaker, and you can definitely check out the website. All right, that's it. Thanks for listening, everyone.